next point is the law of diminishing marginal rate of substitution implies that the curves flatten out. So again, this is a very ideal situation. It's not ideal as in it cannot be expressed in the real practical life, but it's something that we assume to be very normal. So that's the norm. We might have situations where this point does not hold. We might have exceptions to this point, but in general, considering normal goods, assuming normal goods that people usually want, this point holds. So what do I mean by law of diminishing marginal rate of substitution? So as I mentioned before, the marginal rate of substitution refers to the slope of the IC. So what I'm saying is diminishing means decreasing, that is lowering in magnitude. So I'm saying that the marginal rate of substitution lowers gradually. That means the slope lowers. If I'm talking about slope, I essentially mean that the curve flattens out. So the slope decreases implies that the curve flattens out. So you see at this point, the curve is pretty steep. It's pretty steep. And as I move from the right direction to the left direction, you see the curves all become flatter. The more I move towards the infinite positive direction of the x-axis, the more the curves flatten out. Why? Because along the same indifference curve, so let's talk about the same indifference curve. As I increase my consumption of good x, in order to remain on the same indifference curve, I need to decrease the amount of good y. And this exchange changes its rate. So the exchange of good x and good y changes the magnitude of the rate of change. And the consumer is reluctant to give up on y. So let's take a hypothetical example. Let's say we are at a very optimum situation where I have 5 units of good x and 5 units of good y. If you're not, or if you're being bored with the notation of good x and good y, let's say I have 5 units of chocolate and I have 5 units of, let's say, what do you like? Do you like tea? Do you like coffee? Let's keep it simple. Let's keep it a glass of water. So let's say I have 5 units. Let's say I have 5 units of chocolate and I have 5 glasses of water. Now, what my mom does is, my mom says Cadbury's are chocolates. Okay, let's keep it that way. My mom says, now what we do is, let's say my mom says chocolates are not good for health. Chocolates are not good for your teeth. And what my mom does is, she reduces the amount of chocolate in my hand and she increases the amount of good, what was I plotting here? Water, yeah. She increases the amount of water, or she increases the glasses of water that I have per day, and she says that it's very good for health. And what she does is essentially she decreases the amount of good x at my hand and increases the amount of good y in my hand. As per the indifference curve, it says that I am still on the same indifference curve. So that essentially means those two combinations do not give me different amount of utility. But what happens is, next time when my mother at least plans to reduce the amount of chocolate that I have per day or per week, I become reluctant to do so. So the consumer is reluctant to give up a particular commodity when he or she has less of that already. So if I go in the other direction, let's say I have some amount of reluctant to give up y, so we are going in this direction. So as I took the example of chocolate and water, I was reducing the amount of good x. So let's say this time I'm reducing the amount of good y. So I have this amount of good y and this amount of good x, and somebody asks me to reduce my consumption of good y. So what I do is I reduce my consumption of good y to this amount and I increase my consumption of good x to this amount to stay in the same indifference curve IC1, which gives me the same amount of utility. So I'm not better off and I'm not worse off, and I'm as happy as I was before. Now what I do is, if I keep on trying to reduce the amount of good y that I consume and I keep on trying to increase the good x, you see, when I was doing this conversion, when I came from this point to this point, I reduced this amount of good y and I increased this amount of good x. But if I move from this point to this point, I am reducing a very small amount of good y. On the other hand, I am increasing the amount of good x a lot. So what I'm essentially is like, I really don't have a lot of good Y. Why are you taking away so much amount of good Y from me? Please do not take them away. At least give me a little more of chocolates. At least give me a little more of good eggs. So that's the basic story. I already have less of good Y. Why are you taking them away from me? That the consumer is reluctant to give up Y. And that is what makes the marginal rate of substitution diminish. So that is what I mean by the law of diminishing marginal rate of substitution. Again, this is an ideal case. Not all situations follow this rule. There are situations where this does not hold. Essentially, when we have linear indifference curves that we'll talk about later, the law of diminishing marginal rate of substitution does not hold. But in general cases, when we are assuming normal goods, when we are assuming normal consumer pattern preferences, we assume that the law of diminishing marginal rate of substitution holds. The final thing that we'll be talking about is the fact that indifference curves are non-intersecting. So you might be wondering why I changed this direction, changed this diagram rather. Why I did that is I am assuming that the previous diagrams, the diagram where all the indifference curves were non-intersecting, I'm assuming that diagram to be true. But why? We need to answer, or we need to rectify, if possible, improve, or if it's right, then justify why indifference curves are non-intersecting. So we have a little proof for that. What I do is I say that the consumer is indifferent between A and B and A and C. So I have here two indifference curves. I have indifference curve 1 and I have indifference curve 2. So when I'm considering indifference curve 1, I see that point A and point B lie on the same indifference curve IC1. By definition of indifference curve, I can say that any consumer, at least the consumer who has this preference pattern or this indifference curve maps, that consumer is indifferent between point A and point B, that is commodity bundle A and commodity bundle B. So whether the consumer consumes this amount of good Y and this amount of good X, or this amount of good Y and this amount of good X, the consumer is indifferent between that. So the consumer does not essentially become better off or worse off when he flips between commodity bundle A and commodity bundle B. So that is what I mean when I say consumer is indifferent between A and B. That is when I'm considering indifference curve 1. What I do next is I assume indifference curve IC2 this time. So I'm assuming a different indifference curve this time, and what I see is the consumer is essentially, again, by the same logic, indifferent between commodity bundle A and commodity bundle C. That is, the utility derived from the commodity bundle A is the same as the utility derived from commodity bundle C. So the consumer is indifferent between A and C. Next, what I do is, by transitivity, the consumer should be indifferent between B and C. So let's say I have given you 5 chocolates and 5 chocolates and 5, what do you like other than chocolates? Toys, maybe? Yeah. Let's say I give you 5 chocolates and I give you 5 toys. That's probably, let's say, commodity bundle A. That's 5 chocolates and 5 toys. And I give you 0 chocolates and 10 toys. So you say that you're indifferent between 5 chocolates and 5 toys and 0 chocolates and 10 toys. That is, you're indifferent between A and B. The next day, I again give you 5 chocolates and 5 toys. This time, I give you 10 chocolates and 0 toys. So I give you a choice between 5 chocolates, 5 toys, 10 chocolates, 0 toys. But you say that you're again indifferent between both of them. So you're essentially combining both of them. You're indifferent between 5 chocolates, 5 toys, 0 chocolates, 10 toys, and 10 chocolates, 0 toys. So that essentially means you're also indifferent between 0 chocolates, 10 toys, and 10 chocolates, 0 toys. That is what I mean by the property of transitivity. Consumer should be indifferent between B and C. So if you're indifferent between A and B, and you're indifferent between A and C, you should be indifferent between B and C as well. That is, the consumer should be indifferent between B and C. However, if you're indifferent between B and C, shouldn't they be lying on the indifference curve? Shouldn't they be lying on the same indifference curve rather? But you see, by the property of non-satiety, diagram shows consumer prefers C over B. This indifference curve, IC2, at least considering point B and C, IC2 is lying above IC1. That essentially means that C is preferred over B. C gives me more amount of utility than B. So Point number 1 says that I'm indifferent between B and C. And point number 2 says that I prefer C over B. How can both of them essentially be fulfilled at the same time? You cannot fulfill condition 1 and condition 2 at the same time, unless of course B and C are the same points. So when I say that B and C are same points, essentially what I mean is IC1 and IC2 coincide with each other. There's no such diagram as such. IC1 is the same as IC2 and B and C are the same points. So that is what I mean when I say indifference curves are non-intersecting. What I did here is I made an assumption that I can be indifferent between A and B and A and C. And what I find by the property of transitivity is that I should be indifferent between B and C. But what I find from the property of non-satiety is by the diagram, I should prefer C over B. So these two conditions contradict each other. Hence, by using the property of contradiction, I've proved this using contradiction. What I see is that if I use this assumption, I am arriving at two contradictory solutions, and that means my assumption is wrong. So consumer cannot be indifferent between A and B and A and C at the same time, which essentially means that ICs cannot be ICs are non-intersecting. That is, ICs are always non-intersecting and they cannot intersect each other. So that essentially ends our discussion on the assumptions of indifference curves. And in our future videos, we'll be talking about the different types of goods based on the shape of the indifference curve. So I mentioned before that there are goods which do not have a downward sloping indifference curves. There are goods which are not preferred by individuals. In that case, maybe the property of non-satiety does not hold. There are certain exceptions to the assumptions that we have made, where we do not consider the general goods that we have. We do not consider the norms that we have under the ordinary conditions, and we'll be talking about that in our future videos.